forwarding techniques? Did you discuss this?
No,
No, sir.
sir.
No, sir.
Here it's talking about the delivery, forwarding, and the routing. Okay, so in case of the delivery, the way packet is handled by the underlying network layer, it's called the delivery. So delivery means here that you are going to be sending that the packet from the sender to the receiver, right? So for sending the data from the sender to receiver, you are going to be maybe face the several intermediary nodes. So in that the network, in each nodes, how that the packet is going to be handled into the network layer, right? I mean, it should need to be handled in a way that, I mean, you are sending a packet from the sender to an intermediary node or router, so that the router after receiving it, so it needs to be work with it. Okay, and then actually after work with it, then it is going to be sent to that the next node. So this way the packet is going to be progressed, so that the data and receiver, that, I mean, the data is sending that the packet, and the receiver is receiving it, so that the complete fact here is going to be that the delivery. So there are two key network layer functions we are having here. So one is the forwarding and one is the routing. So he said that move packets from router's input to appropriate router output, and the way packet is delivered to the next station. So you already know that from the Cisco packet tracer in the lab. So you know that the router is actually receiving that the packet from that the incoming port, and it is connected with maybe the different other routers. So it is going to be saying that the packets to the other routers, so that the output port. Okay, so that the it is talking about here that, I mean, the packet you come here into this router, so that means you are going to be sent that the packet to that the next router, right? So for example, by checking that the from the packet, the source IP address, destination IP address, and data. So from that the destination IP address, it is going to be check the network address, and based on that the network address, I mean, the router, you're going to be have the routing table, so that the network address you have calculated, router has calculated from the packet, he is going to be check that it match with that the which network address in his routing table, and based on that he's going to be decide that which node he is going to be send the packet next. Okay, so that the packet you are sending next, that we call that the forward. Okay, forwarding the packet from one node to that the another node. So this is what is saying, that the way packet is delivered to the next station, so one node to that the another node actually. And the routing means here determining the route taken by the packets from the source to destination, the way the routing tables are created to help in forwarding. So that means we already said that to find a I mean, to find a path between that the source and destination, so we are going to be use the routing, we are going to be use the routing algorithm. So that routing, through that the routing algorithm, first you should need to be find out that, I mean, a path between the source and destination, and after discovering the path, you are going to be send that the packet through that the path. So this is what is saying, that determine the routing is determining the route taken by the packets from source to destination, actually the way routing tables are created to help forwarding. So when that, I mean, you are going to be created the path, right? So that means on that time, each node are going to be has a routing table, and by following the routing table, actually it is going to be send the packet from one node to that the another node. Okay, so the analogy is telling that the routing is a process of planning the trip from that the source to destination, and forwarding means that process of getting through single interchange. Okay, so this is what already, I mean, the better practical example we have seen into the lab. Okay, so we know that the router here, he is getting the packet. From that the packet, he is going to be get that the destination IP address, he is going to be calculate the network address, and by after calculating the network address, he is going to be match it with that the his routing table, and then he is going to be decide that in which router he is going to be send the packet next. So we have already, I mean, said here that, I mean, already we have done it with that the static routing, rerouting. So we have seen that how it is going to be done over there. So here, I mean, this is what is saying, the routing algorithm determines end-to-end path through the network, and forwarding table determines local forwarding at this router, so that the from the router has received the packet, in which router it is going to be sent the next. So it is going to be decide based on that the forwarding table. Okay. So now here the delivery we are talking about, the delivery, there are two types of deliveries. You are having the direct delivery and indirect delivery. So what is the direct delivery and indirect delivery? That is going to be easily understandable from these two examples. So you can see that there is a router and there is a network, that the network is connected with that the router. So in this network, you're going to be have 1 to n host. So say that one of the hosts from this network want to communicate with that the other host, as because they are into the same network, so that the communication they are going to be make themselves, that is known as the direct delivery. And if you're looking to that the um, so we see we have seen that, I mean, in that the networking lab, that in the under the router there is a switch, and from that the switch we are having the two computers. So these two computers actually, when they are communicating with each other, so they are sending the packet to each other, that is that we call actually the uh, direct uh, direct delivery. And if you're coming to that the right side one, so you can see that this router is connected with the two different network. So that means if your source is in a network and that your destination in another network, okay, that on that time we call that the delivery is going to be happen between them is going to be known as the indirect delivery. Okay, so that means if I'm having the more routers here, for example, that there is no connections, for example, and this connection has been given with this router, so that means this is also going to be known as an indirect delivery. So if you are trying to understand that, I mean, one thing that it said, the packet goes from the router to router until it reaches the one connected to the same physical network as its the final destination. So that is the indirect delivery, and if the last delivery is always the direct delivery. Okay, so if it is an indirect delivery, the last delivery is going to be always direct delivery. Why? Because from that the router, you're going to be send the packet to that the destination.
Destination.
Right. So this is going to be your direct delivery. So same example, if I'm taking that there are some other routers, no link is here, but here it is the link. So that means from this router, you can send that the packet directly to that the host. So that is going to be the direct delivery. Is it clear that what is the I mean difference between the direct and indirect delivery?
Yes, sir, clear.
Very good. Thank you. So the next thing is coming that the forwarding. If you're talking about the forwarding, forwarding means to place the packet in its route to its destination. It requires a host or a router to have a routing table. When a host has a packet to send, or when a router has received a packet to be forwarded, it looks at this table to find the route to the final destination. So we already said that, I mean, when a packet is going to be received by a router or a node, so it is going to be take the help from that the routing from that its routing table, that in which node that the packets is actually going to be sent next. So there are different techniques we are having for the forwarding. So we can see that here we are having the two techniques. One is the route method technique, and another is the next hop method technique. So this is the example. With that the example, we'll try to understand that both of the techniques. So look that, I mean, in the routing, the here that the routing tables we are having for each of the nodes. So here we are having a host in this network, and we are having a host B in the another network. In between, you are having that the two routers as well, R1 and R2. So in case of the routing method, what it does, so these are the tables actually for the routing table A, routing table B, routing table R1 and R2. So this is actually considering this is the source and this is the destination. So that means to go for reaching from that the source to destination, so you are going to be have, you are going to be follow that the routing table of host A, that is actually this one, and then the you are going to be, when it is going to be sent to that the R1, so from the R1 you are going to be use the routing table for sending to that the R2, so that the R2 has the routing table, with that actually it's going to be able to reach to the destination. So you can see that in the routing method is, so what happening is that each node is keeping, so this is the source, this is the destination, so each node here is going to be keep that the whole path for reaching to the destination. For example, from A, if you want to go to that the B, host B, then the path is going to be A to R1. So this is the destination is host B, and A to R1 and R1 to R2, so that the R2, and R2 to that the host B, so that the host B. Okay, so that means it is keeping that the complete routes from that node to that the destination node. From the router one, if you're looking, Then the router one is also, I mean, the if the destination is host B, then router is one is going to be keep the next hop is the R2, so it is keeping that the R2, and then from R2 it is going to be host B. In the case of R2, that is keeping that the routing table for host B is that the directly that host B directly it can reach from that the router 2. So this is how that the routing method okay, that it works, that the route method. So now if you're so what is that the goal here, that I mean it's actually quite the routing table we are having for that the different nodes in this network, right? It is only few nodes example, but think that if there is a more routers in between, one to n routers in between the source and destination, then the routing table is going to be very I mean the weight of the routing table is going to be very high. So that is actually going to be the one of that the uh, challenge, that actually how actually we can make the routing table of a node lighter with that the lighter weight. Okay, so that I mean that's why that I mean to overcome this problem, that we are having the next hop method here. In the next hop method, what is happening, look that the node does not need to be keep for going from that the source to destination host A to B. It does not need to keep the whole record of the path. Instead of that, it is telling that for the node A in the table, it is going to be keep the destination is host B and the next node is my R1. So it is going to be only keep that the next hop information in the routing table. So that is why actually it's called the next hop method. So now for the router one, so it is for the host destination B, it's just keeping that the next hop that is the R2, so that you can see that next hop only next hop information has been kept. So now for that the destination B, from that the R2, so it can be directly reached from that the R2 to B, so that is keeping as empty. So this is what the difference. So you can see that if we are following that the next hop method, then actually we do not need to be keep the record that the total paths from a node to the destination, total paths you do not uh, need to be stored. So this is how that you can actually reduce the weight of that the routing table of each node. Is it clear?
Sir, if there is another router between R1 and R2, sir, what will be the next hop and route? Can you shortly explain, sir?
Yeah, so if it is that another router here, so that is R2. Okay, and if it is like that, then here it is going to be one. In that case of route method, is going to be R1, R2. Sorry, and there is going to be R3 according to our R2 and comma host, isn't it? So
Yes, sir.
we want to go from the host A to B. Then that the route is going to be R1. The next one is R3. Next is R2, and then the host B. So that is the complete path. For that the R2 R1 table, it is going to be the R3 comma R2 and comma host B. Okay, so complete path it is keeping for that the route. Okay, so there is
Yes,
going to be the
yes.
another table is going to be for the router 2, right? After the router 1. So we are having the router 2 here. So for that, there is going to be also another table. And in that case, if you're coming here, that it is going to be keep that the host A and that next hop is R1. Then for the router 1, the table is going to be host B, not A, host B, and the next hop is going to be the R3. It is going to be R3. And for the R3 routing table, it is going to be the destination host B, and the next node is going to be R2. And then for R2 it is going to be destination is the host B, and that it can be directly reached. Clear?
Yes, sir. Clear. Thank you, sir.
Yes, sir.
Yeah, there are more methods we are having, that the network specific method versus the host specific method. So in the host specific method, what is happening, look that I mean here we can see that R1 and in its two side there are two networks, N1 and N2. So in the N1 we can have one to n host, as well as in the N2 we can have one to n host. So it is showing that only the one node in the N1 and the four nodes in the N2, like A, B, C, D. So in case of that the host specific method, what it is doing, that in the source node the routing table it has. So for that the A, B, C, and D for the network N2, it is keeping all that the nodes record. that with that the next hop method, that okay, if you want to reach from S to A, then that destination is A, next stop is R1. If you want to go from that S to B, then destination is B, next stop R1. So that means if you are having that here 1000 note, for example, then for each 1000 notes you are going to be keep that with their node name, and the next stop is R1. You are going to be recording the routing table. So you can understand that routing table weight is going to be quite high in that case. So for overcoming this, that network specific method comes. So what does it says that okay, if you want to go from that the S to A B C D of N2, so it is keeping that the destination as a N2. Okay, that from S wants to go to that the network 2, and your next hop is R1. So what is going to be happen there is actually that if there are 100 nodes or ABCD or 100 nodes, 1000 nodes, whatever it is, that is actually connected with the N2. So if you're reaching to that the N2, that the destination node itself, it can be easily found. So this is going to be the better approach than that the host specific method. Is it clear?
Sir, can you please shortly again tell why network specific is better, sir?
Yeah, that it is not keeping the for each of the nodes of N2, it's not keeping that the record separately. Instead of that, all this network into that the network number 2. So it's saying that the destination is N2 and the next of one is R1. So if a packet is coming to that the N2, then whatever the nodes, in whichever node that it has been assigned, say that it's assigned to B, so it is going to be automatically gettable B from that the N2. Understand or not?
Yes, sir. Clear, sir.
Thank you. So now if you're going for that the default method here, it's saying that another technique is to simplify routing is called the default method. Figure shows host A is connected to a network with two routers. So you can see that the router 1 and router 2 are connected with N1, and there is an N2, and there is the rest of the internet. So you say that router 1 routes the packet to the host connected to the network N2. So yes, if host A wants to send any host present into the network N2, then actually he is just keeping the record that okay, the destination is N2 and the next router is 1. However, for the rest of the internet, router 2 is used. So if it is host A is sending a packet that is to a host destination host, if that is not the part of the N2, that means that the packet is need to be sent through that the R2 router. So you say that to instead of listing all the networks in the internet network, host A just have one entry called the default routing, and that is normally come with that the 0.0.0.0 address. So what is happening here, that if host A can reach to a computer, to a destination computer by a router, then actually it is going to be reached there. But if it is not, then it's not really possible that for every network in the internet you are going to be keep the records in the routing table of host A. Okay, so what is going to be happen, that okay, that the network is directed connected with the R1. So if it is the destination host is any one of the host of the N2, so you are keeping that destination is N2 and the next of is R1. But if it is not found that where is that the destination host, that means it's not present into the net 2, so that the packet is going to be sent through that the default router to the rest of the internet. Is it clear?
Yes, sir.
Mhm. So now come to the forwarding process here. He said that assume that the host and routers use classless addressing, because classful addressing can be treated as a special case of classless addressing. So we have already discussed about that the IPv4 addressing, and there we have know that there are two types of IPv4 addressing, that is the classful and classless. So it is telling that assume that host and routers use classless addressing, because classful addressing can be treated as, yeah. So we have seen that there are different techniques, because that we are having the fixed number of addresses, 4.2 billion addresses into that the IPv4 addressing. So that to use those limited addresses, we have actually used the different techniques. So one of the techniques actually has been we have discussed the classless addressing. So it is possible that in the internet a network is a part of that the classless addressing. So this is actually telling here that It can be a special case. I mean, it can be used. Said assume that host and routers use classless addressing because classful addressing can be treated as a special case of classless addressing. It said that in classless addressing, the routing table needs to have one row information for each block information for each block involved. Okay, so yeah, the table needs to be searched based on that the network address, the first address in the block. So we know that actually that we have seen that, for example, this is my source IP address and this is my destination IP address. Okay, and this is my data. So we said that the packet will come like that. Okay, to router from a router to another router, right? Packet. So that the destination IP and that the this is the source IP. So when this is going to be received in the router, this packet is going to be received by the router. So what the router is going to be do? This the router is going to be do here. It's going to be take that the destination address, start the destination address, and from that the destination address, he is going to be find out the network address, and then he is going to be search the table that the found network address is matched with that which network address. And if it is matching with that the any network address present in the routing table, then he is going to be use the interface to send that the packet. So here, what is the problem? It has been said, look, that unfortunately the destination address in the packet gives no clue about the network address. So we know that. I mean, the here that the IP address you have got, so that an IP address you have got, so that the IP address, I mean, is not that the destination IP address is not that the network address. So you should need to be actually find out that the network address from that the destination address of the packet. So he said to solve the problem, we need to include the mask slash n in the table. We need to have an extra column that includes the mask for that the corresponding block. So what it is trying to say is that we know that in the classless addressing, it is going to be the slash n, right? So we have said that if it is the slash 8 or it is that the, I mean, with the IP address, of course, okay, with the IP address slash 8 slash 16 and slash 24. If it is like that, then uh, this is actually similar to that the class A, class B, and class C, uh, like that the classful addressing. Okay, but if it is different, any numbers different than this 3 for the n, I mean slash n, then actually that is going to be the pure classless addressing. So look that as I said that there can be the in a network there can be a part the router is connected to it. So you'll see that here actually that the router one, that you can see that we are having the 4 networks has been connected here. And this 4 network, if you're looking to the address, you can see that slash 25 slash 24 slash 26 slash 22. So that means by seeing these addresses, you can easily understand that these are the classless addressing. Okay, so if a packet is coming into that the router R1, so from that the packet destination IP address, you should need to be find out the network address. So remember that as because the networks are here with that the classless addressing, so that means you need to be keep an extra column for the router, as because they are the classless addressing. So there should need to be an extra column in the router that is going to be the mask n. So if you're keeping that, then the network that the destination IP address you have got that. So with the slash n, you can actually find out the network address. Okay, that it is going to be seen into that the next example. So this is the extra, I mean, in case of the classless addressing, if in the network the classless addressing has been used, the router should need to be keep a extra column, that is the mask n, and that the mask n is going to be put, I mean, when you're going to be add that the network information, then highest number highest value mask is going to be written first, and then the second highest, then the third highest, something like that. So you can see that we are having an example here that make a routing table for the router one using the configuration in figure below. So you can see that we are having the this figure has been given to you, so it has been asked to prepare this table. So you can see that the mask you are having, so you are having the 22, 26, 25, 24. So you can understand that slash 26 is the highest. So that is what you are That is what you are writing first, the 26. So what is the network address? 180.70.65.192. So that is actually you have written. So for going from that the R1 to this network, do you need any next hop? No, it is the direct neighbor. So you are actually not writing any next hop. So this is actually um, the interface number that you have for this reaching from R1 to that this network. The interface number is M2. So you are adding that the interface number M2. So now the next, you are seeing that slash 22 slash 25 slash 24. So is the highest 25. So you are adding the 25 here. What is the network address? 180.70.65.128. So this is also the directly reachable from the router to this network. And what is the interface? That is the M0. So you have written that interface is M0. Then out of these two, that 24 is actually the next highest. So that the slash 24. And then you are writing that the network address 201.4.22.0. And yes, it can be reachable directly, this network reachable from the R1 to this network reachable directly is possible. So that means no next hop, and the interface number is M3 here, so that we are writing the M3 interface. So the next one left, that is that the this one, so 22/22, so that the network it is 2014.16.0. So you can see that 2014.16.0, it can be, this network can be directly reachable from R1. So that is the M1 interface actually you are writing. There is no next hop actually, as because you can directly reach to the network from R1. So now that a packet has reached to that the R1, right? So if it is after finding the network address from that the destination address, um, if it is finding out that the packet destination, uh, from the packet destination the network address that you have found, okay, so it is going to be apply with that mask 26 of the routing table with the mask 26. It is going to be checked that network address is matching or not. If it is matching, then it's going to be send the packet to throw that dam to. If the found network address from the packet then apply to the 25 and found network address that is matching with this network or not. If it is, then it's going to be sent to the interface. If it is not, then it is going to be followed with the 24. So now it is going to be apply that 24 and find out that the network address from that the packet destination address. So found network address is matching with this or not. It's going to be checked. If it is match, then it's going to be sent to that the packet through that the empty to that network. If it is not matching, then it is going to be again apply that uh, slash 22 to find out slash 22 and that the packet destination address to find out the network address, and that network address is matching with this or not. If it is matching, then it's going to be sent to that by using the M1 interface to the network. And if it is not matching any one of them, then what is going to be done? Then the packet is going to be sent to, it is saying the any mask, it can be the any network address, so it does not know the router does not know them, that's why it's any, and it is going to be use the next hop address, that is the 180.70.65.200, and that is going to be sent through that the M2 interface. Clear?
Yes, sir.
Sir, why other mask has no next hop, but the last one has next hop, sir?
Yeah, because the router one can reach to these four networks directly. Okay, so
Yes, sir.
router router one knows about these four networks. Okay, that this one and this one, they are directly connected with the router, right? So router knows about these networks. So if they knows about the networks, that means they are the directly connected. These networks are directly connected to R1. So there is no need of the next hop. It can easily reach to that the network directly. Understand? But
Yes, sir. Yes.
if it is not matching, then the router one does not know that actually who is going to be the destination network, because he knows only these four networks. He doesn't know about that the other network. So what he's going to be do is that he's going to be send the packet to that to the internet, rest of the internet via the this next of address, and by using the M2 interface. Clear?
Yes, sir. Clear, sir.
So you have to at your home that the fact here is that you have to practice, you should need to be take that the only this figure, and from this figure prepare the routing table by yourself. Okay, not by not seeing this table information, prepare your table by yourself, routing table for R1, and then check it that you have correctly prepared it or not. And again take this table only and draw that the network layout by yourself, and then again check that you have drawn that the network layout correctly or not. So these are the two things if you are doing that. First, you are drawing this and preparing the table yourself, and checking it that you correctly doing it or not. And then again that this table you are taking and you are drawing this the figure by yourself, and you are seeing checking, comparing and checking that, I mean, you have drawn it correctly or not. So if you're doing that, I am quite sure that the rest of rest of the part is going to be very easy to understand. So look that here we got a example. So you say that show the forwarding process if a packet arrives at router 1 in figure 7. So this is the figure it's talking about. This is the same figure that what we have seen here. So with the destination address, so that the address has been given 180.70.65.140. So this is the address has been given, and it has been asked you show the forwarding process if a packet arrives at R1 with the destination address this. So the forwarding, so this is that the routing table actually you required for the R1. Okay, so this is the same figure actually given here. So this routing table you required actually to calculate this part. Can you remember that the classless addressing, that how to find out the first the block? So this IP address has been taken from a block. So that what is going to be the first address of the block in the classless addressing? How you are going to be find out the network? I mean, first address of a block in the classless addressing. Can you remember? So you should need to be apply here first 180. Okay, and then right there. So you need to take this IP address, and you should need to be with the first you're going to be apply here 26, as because in the routing table your first mask is 26. Okay, so now for this, how to calculate that the, I mean, first address, that the first address is going to be the network address, that we know that in a block the first address is going to be the network address. So to calculate this, what you have to do, that you have to convert this IP address to that the binary, and that slash 26 means what? The 26 1, and rest of the bits are 0. And then you have to do the AND operation to get that the first address, okay, or network address. Okay, so you are going to be, you'll take that the network address and you'll check with that it is matching or not. If it is matching, then you are going to be, you will say that the packet is going to be forwarded to this network via the M2 interface here actually. So now, okay, I think you can show that. Yeah, so you can see here that in case of classless addressing, what you have done, in case of classless addressing, yeah, so this is what, that this is a IP address has been given to you. So you have taken this IP address and converted to that the binary, and then the 27 means here that 27 1, and the rest of the bits are 0, and then you have done the AND operation. Can you remember now that how to find out the first address or network address? Hello, are you listening?
Yes, sir.
Yes, sir.
So uh, you already know that, I mean, in case of doing the AND operation, so you need 1 1 to get a 1. All other cases it is going to be 0. So we say that if there is the all ones in the bottom, right, up to that whatever the we are having on the top, that is going to be the result. You can see that up to this the result is same, isn't it or not?
Yes, sir.
And because you are getting here all zeros, so that means there is no possibility to get 1 and 1. So that means the rest of the bits are going to be 0. Okay, I think, and can you please tell me that how to find the last address of the block in the classless addressing?
Sir, all ones. Sir, except net ID.
Sorry?
স্যার নেট আইডিটা লক করে বাকি সবগুলা ওয়ান করে দিলে লাস্ট অ্যাড্রেস।
No, 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 no. I say that what is the rules? What is the rules? This is the classless addressing, okay? So the rules are going to be, of course, you should need to be converted to the binary, and that the address you are having, that network address, the 27.1 and rest of the bit 0. So it is going to be just opposite. 27 zeros, ones complement that you have to do. Is that the ones complement you have to do that 27.1. It was 27.1, so 27.0, and rest of the bits are going to be 1. So now you are going to be do that, I mean, or operation here. You forget, completely forget. You should need to be study them. It's very important for your, I mean, the finding that the first address, last address, first usable address, last usable address. Okay, it's very, 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 very important for your midterm and final examination. I mean, for the classful and classless both is very important. Okay, so we know that the technique. So let me do that example actually. One we are having that the two more examples after this, so I am going to be only do this to show you. Just a moment. Microsoft Word on the screen.
Yes, sir.
Yes, sir.
Mm, take the IP address here, that is the 180.70.65.140. Is it correct? If I'm doing writing something wrong, please, I mean, correct me. Okay, so now what do we have to do that? I mean, we have to use that the magical numbers, that is the 1, 2, 4, 8, 16, 32, 64, and 128. So you are going to be converting to that the binary now. So remember that according to the routing table, we should need to be first apply the /26. So I can write here the /26. Okay. So now we are going to be converted to the binary. So if you're making it binary, then this is the 128. It is 180. So 120 means 1. And what is that? Going to be 1. And then you're having the 64 nodes. So this is going to be 0. 132, 160. So that is going to be 1. And 160. So this is going to be 0. And 8, 60, 160. Oh, no, no, no. This is going to be 1. Right? Because 128 plus 32, it's 160. 160 plus 16, it is going to be 176. And we need 4. So that means it is going to be 0, 1, 0, 0. Is it correct? 180 that we have converted to the binary. Is it correct? Are you with me?
Yes, sir, correct.
Yeah, please, I mean, concentrate on this. I mean, if you are seeing this example, one example, then I think you'll be able to calculate, I mean, able to do that every examples if you are understanding this. So it's very important. Please focus on. Okay, then that the second one is going to be your 70, right? So find out that this is the 64 and you need 6. So these are the two. So it is going to be 0, 1 and 0, 0, then 0, 1, 1, 0. Is it correct? 64 and 6. Yeah, 70. Then we are
Yes,
having 65. 65 means 0, 1, 0, 0, and then 0, 0, 0, 1. Is it correct? 65? Yes.
yes,
So
sir.
the next one is 140. So 120, 128 100. Then 16 if I'm taking, then 30 132 144. No, 16 I cannot take. 140, right? So that means 120 plus 8, 36. 36 and 4. Is it correct?
Yes,
Yes,
sir.
sir.
Correct.
Yes, sir.
Okay, so this is that the conversion we have done, and we are applying now that the 26. So that means there are going to be the 26 one. Okay, 26 one. So 24 and 26, and rest of the bits are zero, right? Understand or not?
Yes, sir.
Okay. Now if you're okay, so now if you're doing that the AND operation, so you know up to this because it is 1 and 1, it is going to be 0, right? So that means up to this whatever on the top you are going to be have, that is going to be the result. So you can check it like that. 1 1 is 1, so 1 0 0 1 is 0, so 1 1 is 1, 1 1 is 1. Then you are having 0 1, it is 0. Then you are having the 1 1, so it is going to be 1. Then it's 0 1 1 0 0 1 0. So the next is going to be 0 1 0. Sorry, 0 1 0, and 1 1 is going to be 1, 0 1 0 0 1 0, and then it is 0 1 0, so 1 1 1 1 1 1 0 1 0, and then 0 1 0 1 1 1 0 1 0 0, and then 0 1 0 0, and 0 1 0 0 1 0 0 1 0 1 1 1, right? 1 1 1, and then you are having that 1 0 0 0, and then 0 0 0 0 0. So this is that the AND operation we have done. So you can see that, I mean, whatever you had up to this, right, on the top, you are having the same result. Okay, so that means if I'm now converting it to that the decimal, so you know that it is 180 dot, sorry, 180 180 dot 70 dot 65 dot. So you are having here only one, right? So that means 128. So this is the network address actually you have found. Okay, so after calculating that, so you can now check that it is 180 70 65 128. Does it match with this network address in the routing table? 180.70.65 192. Does it match?
No, sir.
No, no, sir. Sir.
So that means it is not for that this network. Okay, so now the next, now it is going to be apply the next highest mask that is in the table, that you can see the 25. So it is going to be applying now 25. So make it 25, and the things are going to be same, only this is going to be 25 1 and rest of the bit 0. So if you are doing that again the AND operation, so you are getting the same result. So this is going to be result again 180.70.65.128. So now check that this address and this address is matching or not.
Yes, sir.
Yes,
Yes,
Matching.
sir.
sir.
It's matching.
That means the router one understand that the packet he has received, that the packet is going to be uh, for this network. Okay, and it is going to be send the packet through that the M0 interface, right? So you can see that M0 interface. Understand or not?
Yes, sir.
Yes, sir.
So we are having here the two examples here. So with the different address, so same way you can do that. You can apply it for the 26 first. It is not going to be matched. 25, it's not going to be matched. 24, it is not going to be matched. And you'll see that for the 22, it is matching. So it is the packet, the router one is going to be send the packet through that the M1 to that network. Okay, so it's telling me here, yeah, so this one is going to be matched with that the third one, sorry, the 24, this one it is going to be matched. Okay, so you can do this, practice this at your home, similar way that I have shown into the Microsoft Word. And this is actually not matching to any one of them, so you have to apply 26. You are going to be see that it's not matching, and not for the 25 matching, not for the 24 matching, not for the 22 matching. So that means it is a bypassing packet. So the packet R1 is going to be send the packet through the next hop. This is the address to the internet. Okay, understand?
Yes, sir.
So this is how I think that we have complete this lecture. But in the next class, we are going to be discuss about the two very good terms that you should need to be know about them, NAT and PAT. Okay. So after discussing these two topic, then actually we are going to be close this chapter, and from the next week we'll start the chapter number 8, data link layer. Okay.
Yes.
All right. So it's enough for today. Thank you very much.